Hi, this is Christopher Rowe giving my final presentation for the data analysis using Python class. Um, I want to keep this within the 10 to 15 minute suggested duration for the presentation. So I have a few PowerPoint slides that I'll go through quickly and then try to get to the demonstration and move along my Jupyter notebook where I'd like to show all of the components of the final project. So my project is called Media Log Data Analysis by Personal Rating, Viewership, and Box Office. I've kept the title from my proposal, and this is a presentation by me, Christopher Rowe. So the flowchart remains largely the same from the proposal as well, where I'm taking a data from Microsoft SQL Server database. Because of some difficulties with connecting directly to the database, I'm using exported CSVs from the database and then doing some processing with Python 3 scripts using the pandas and matplotlib libraries as outlined in the proposal. Um, the output, I have a few visualizations of data that's been processed in Python 3 for the output. So there are a lot of lessons learned in this project. First of all, and this will become apparent during the walkthrough, but the CSVs that I'm exporting by default from Microsoft SQL Server don't have column heads, and that can necessitate a little bit of processing, which has been covered in the class, in order to be functional. So I go through a little bit of a convoluted way where I read the CSV, export to get the column heads, and then reread that into a new data frame. The pandas timestamp is very useful for data manipulation, but you have to be careful to get your data in the correct format. A lot of times when I bring in data from CSVs, the data is in a string and needs to be converted into a timestamp. Periods is also useful, but in trying to graph some of the periods data, realize that that's not considered the same as a timestamp, so I would not be able to always use the periods data in the same way that I could use dates from timestamps. But the periods was the most useful way I found to do different count operations. To see, for example, how many media items were consumed in a given time. I have an example of that in my final project. But some bigger lessons learned, kind of more macro things, I think representing data with media or anything with a heavy text component can be difficult, especially when graphing. You don't want to get too text heavy. I think it can be useful to think about how you want to represent data and try and have maybe two numerical axes wherever possible. I don't always succeed at that in my project, as you'll see, and the heavy text makes graphs unreadable a lot of times. So I think maybe CSVs is better for interpreting text data, and graphs are better for numerical data. And then secondly, the what will inform the how of data processing. Thus, in a large, constantly developing system like a media log, data visualization will usually be iterative. So by this, I just mean in complex systems, when you're trying to do data analysis, you really want a clear sense of what you want beforehand. And that can be difficult in kind of an experimental setting like this, where you're doing an academic exercise to learn basic technical kind of skills, but that lesson still became abundantly clear as I went through even my own media log. I could see how as complexity scales, you really want your what to be clear. So the exports from the project, I have a few CSVs and images that I export. I'll show an example of one of each, kind of the best of each, because some are good, some are bad in the following slides. And the next steps for future expansion of this project. So as I go through, we see a lot of areas where if I want to improve or make this better, this is very much kind of a rough beginning to what could, if I wanted to refine this project, I would use a library like PYODBC to connect directly to the database. That's something that I found in looking online when I was thinking about connecting directly to the database rather than exporting CSVs. Um, and doing a possible GUI integration would definitely be cool rather than having a script or Jupyter Notebook that runs and does processing. Maybe have some kind of tool that could make things a little easier for a user. I had some challenges in that the database that I have, the computer that I have the database on is different than the one that I do most of my processing on. I don't really have that set up currently to access outside of the Windows authenticated environment where the database lives. So here are some examples of some exports. Here's one of the better graphs that I found, which this is doing a personal rating for media objects consumed by month. It's a little cut off here on the bottom in the slideshow, but I can open the full image in a moment. But basically has the year and the month along the x-axis there. So 2017 1 January going up through 2019 3 March, and then the average. This is the mean personal rating, which we'll see in the Jupyter Notebook of media objects that I consumed that month. So a lot of the mean, it looks like I don't have a huge standard deviation for these ratings, right around 6 to 7 most of the time. But I thought this was a good visualization over time. And then I did an export of a CSV. This is also a little cut off in the PowerPoint, but it's doing some processing in the script that is able to show the movies that I had seen that were kind of net profitable, so that their box office was greater than their production budget. All right, so let's get into the demonstration. So first, real quick as context, this is the a team viewer into my other computer with the database on it. I had 3 tables, a general personal media log, a television information table, and a film information table. And I exported all 3 of these as a CSV and read those into my final project. So now if we go over into my Jupyter Notebook for my final project, I do a little bit of processing on each of the 3 CSVs, so it's split up into kind of, you'll see variables for regular data frames. Then I use the same names except for the B data frame, so you'll see a DFB1, and then a C data frames, DFC1. But we start here, and I just start with reading in the watch log results. I do a quick inspection of the head to see that it's reading in okay, and this is illustrating what I was talking about, that my default export did not have a header. So what I would do is re-export and specify the head from the actual database and then read that in. So now I have my head. It's a little more useful. And it is big, but not so big that I can't just do a quick test to make sure that it's all reading in, all 1177 rows. Then I did just some experimental kind of statistical analysis just to make sure it's working. So like doing a sum of the personal rating and locating a integer, locating a certain cell and seeing what type it is, and doing a mean. Now this is where I found that the date viewed column was still a string, and I needed to do a replacement to make it a timestamp. So gotten used to this in a few other assignments, but I create a loop with the length of the data frame and do, in this case, I had to do an integer locate. Before I've been getting lucky with just kind of doing just a bracket next to the data frame to replace, but I do an integer locate of the specific column and loop through that to actually put in the date time timestamp from pandas and specify the format. Which we learned about a little bit in the class. Sometimes you actually have to specify exactly how it's formatted so that Python can interpret that correctly. And I do that in place. Then I loop through the whole thing just to make sure they're all timestamps, and indeed they are now. I make the timestamp column the actual index, and then here's where I actually get into some different aggregate data that I thought would be useful, especially by personal rating. I wanted to do personal rating to see if it would change drastically over a given period of time. So I do the mean of the personal rating grouped by the year and the month in the data frame. So you see that that's kind of a interesting view here to go by year, month, and then the actual personal rating. And then this is the graph that was briefly shown in the slideshow, and I do that as an output as well. Save that figure to a PNG. And I thought it would be interesting to just see this this described. So as I had said, you can visually see the standard deviation isn't very high. You can see the mean of about 6.3, and some of the different quintile information. Now, I thought that it would be interesting to change this and break it out even further by media type. So I created a new data frame to actually break out the personal rating even further down into media type and by time. And you can see early on when I created this database, I was tracking some media types that I dropped, like miniseries, but you see things like TV, film, video game, podcast, those remain kind of constant over time. But one month where you see like, oh, well, I had a very high average rating for some internet type in this particular month, that would be interesting to go back and see what it is about that content that had such a higher average rating than some of these other types. So then if I want to export that as interesting average data to a CSV, I do that, and that's put into my export folder over here. So I've got a CSV broken down by time and media type. And I continue on. See, this is an example where I try to do a graph of that. And this is an example where I mean the text can be really messy and maybe not the best for data visualization, but necessary if you were to interpret the data by the, you would want to know what the title of something is compared to its personal rating. This is um, this is actually the media type broken down by time, but I didn't include this as sort of the best example of a graph to come out of this project, but still experimented with outputting that, and that came out okay. Um, Here I was experimenting with what if I wanted to do a filter where you had a certain condition, sort of like you would a SQL statement. So I created a new data frame and used this where function to only select the film media type from the CSV. And the only problem was the where clause still contains not a numbers or not or null string values. So I found to clean that up, if I use that, I would also do a drop NA. And here I use the a new data frame and actually locate certain columns that I want, and then drop the not a numbers, and you get cleaner looking data frames. So like here, I wanted certain columns, and I'm able to use the locate function, and that was just an idea that came out of when I did a simple query up here, and it was too messy to just have film, but I want to keep all of these columns. I found this solution by using locate and then dropping a lot of those null values. So this looks a lot better if I was keeping series, media type, personal rating, and I still have all of that. This I was just experimenting with. If you plot something like a series versus a personal rating, what would that look like? And again, this is something where the text just makes it sort of not very useful. Here I'm going on a condition where I want to try a mask. So I'm trying to see what movies or what media items I've given an 8 or higher to. So the way I did that was create a data frame where I mask anything that I gave less than an 8 to and immediately drop those not a numbers and null values. And then I get a nice table of, and this is films only because I've previously, in the previous data frame up here, I already filtered to where media type is just film. So that's why with the combination down here, I'm able to do processing where I'm just seeing films with an 8 or higher. So these are all films that I liked a lot. Then let's say I wanted to do a count of something. I thought this count function was useful just to quickly get a visualization of how many things are in a data frame. And then this is where I started trying to do a count based on a specific criteria like time frame here, and I found that actually using periods was good for having a count of something. So I create a series where I actually convert the index, which is already the time frame, to a period of months. then I look at that series and I see that I've got all of these different, all of these movies that I rated highly, 8 or up, by the monthly period. And then I can actually just do a function called value counts on that series, and per period, I was able to get how many films did I rate highly in a given month. Um, and I sorted the index so that it's actually going in chronological order, and then graph that. And I thought this was a useful graph. Let's say you were not doing a personal media log, but looking at the aggregate data of a lot of users, and you wanted to look at what months are people giving more high ratings to, say, movies. If you thought you were releasing a movie in a certain month, would give you a better chance to have a good reaction. That was kind of my thought. So maybe based on this information, it would be like late year to early year, December or January is kind of where it spikes for me. I know given a larger data set, you would probably have more useful trends and could actually make some valid conclusions. This is almost too small a sample set to make a valid conclusion, but the visualization is there, and I think it's interesting. So then quickly, I think we've gotten through the meat and potatoes of a lot of the processing I did and just sort of duplicate with the other two tables. So I'll go through those quickly. These are the B and C data frames. So again, for television information specifically, I read in my table and then do a quick export so I get those column heads, read it back in, just like I did before. And this time, the processes that I wanted to do was to look at the ratings, the US viewers million. So how many people are watching a TV show? And I group by series and take the average. So this is any show that I've entered episodes for and put ratings for those episodes. It'll take the actual average of those episodes for the ratings. So you're getting more of a sense for the whole series of how highly rated something is. So I had the problem again where it's useful, but it keeps the not a numbers in there for things that don't have the information. So if I drop the not a numbers, do that in place so I can keep the same variable, suddenly I have a more useful ratings information for different series. And I wanted to see what type that was. That is a series, so I can do that sort values again, and suddenly I have the highest rated average series to the lowest rating. So for shows that I've watched, series like The Simpsons, Friends, The Big Bang Theory, those are the three, on average, highest rated shows. Whereas the most obscure or lowest viewed ones are like Billy on the Street, Nathan for You, Who is America. So if I were looking to make a TV show based on this information, and again, it's too small a sample size to really take these conclusions seriously, but you can see if it's a large sample size and you got this info, you might think, okay, I should be making some kind of broad appeal sitcom if I want high ratings based on these results. And then graphing that, the text information, again, I think makes it very difficult because, and we're looking at series from highest to lowest rated, so it's not surprising that it sort of swoops down like this. Um, and I save that figure also here. There's the messy text info, but just testing that I can save. And then for my C data frames, I do some processing with film information. So I read in my CSV, I do a re-export with the column heads, read that in so that I've got more useful data to do some processing on. And then here is where I wanted to look at box office and specifically wanted to sort by series where, because in film, series and title are going to be the same thing. So we're only looking really at series, where the box office is greater than the production budget. In other words, what films are profitable? So I do that processing, I drop the NAs, and then I have this list of the films that I've seen that are profitable. So I export that to CSV. If you are looking at this as like a producer again, you might be able to see, oh, there's a lot of superhero films, or you could do some sort of more qualitative analysis behind what do these films that are profitable have in common. And conversely, could also do something where you wanted to see what films are not profitable, so where their box office is less than their production budget. And then you've got a list of films there. Um, this is similar processing, but what if I wanted to be a little more specific? I track international and regular box office, so maybe I want to not just look at domestic box office, but see what films with international and domestic box office are less than their production budget, and that be a little more selective that these are movies that really did not do well globally. Um, then this is looking at, okay, out of all the films I've seen, which ones are the absolutely top grossing and lowest grossing films. So here I have a format string, and I look at the max box office using some of the functions for statistics, and I see that the top grossing film made about $700 million at the domestic box office. And if I wanted to see what series that was, I do a series call where the box office is equal to, and then I have that same function, and I'm able to see that that was for series Black Panther. And then similarly, what's the lowest box office I have recorded? It's $0. What movie was that for? Brawl in Cell Block 99. So in any case, the large overarching theme of what can be done in this project is that there can be good visualization and data that can come out of large database. So maybe I have one useful CSV and one useful graph, but the actual possibilities of the different processing you can do with all that data is really endless. So thank you for a great quarter in this class. I appreciate you looking at my database project.